2:30 बजे से हम लोग चलो मैं सर से लेता हूँ जाकर
Good morning, dear students. So, today, after completing some subsoil exploration details, in which I have discussed about, in which I have discussed about types of samples, undisturbed samples, disturbed sample, and representative samples. Some samplers, disturbance area ratio, recovery ratio, clearance, stabilization of boreholes, types of boreholes, number and depth of borings for various civil engineering structures, and soil exploration reports. Something which I have not discussed in these things are like I have discussed somewhere undisturbed sample, disturbed sample, and representative samples, and samplers I would discuss in some another lecture, and sample disturbance and area ratio I will also discuss all these things, recovery ratio and clearance. About typical bore log details and soil exploration report already I have discussed. Number of depth and borings I will discuss tomorrow. Now today I am going to discuss control of groundwater during excavation, in which I will discuss the dewatering, ditches and sumps, well point system, vacuum methods, electro-osmosis methods, and all those things. Afterwards I will discuss about the problematic soil and soil stabilization and its method, which is a part of the unit 5th. It is a large unit, and it is the whole unit is theoretical, so I would be discussing on daily basis one topics. So in unit 4th, I have already discussed the types and application of coffer dams, their application, some introduction to sheet piles. Only machine foundation is left. And in pile foundation I have discussed about their classification and their suitabilities, their capacity by static method, negative skin friction and all those things, pile capacity for by dynamic formula, and their limitation, group action of pile number and spacing of pile in group, and efficiency and all those things under reamed piles. Students, the only things left in the unit 4th is a brief description of machine foundation, which I will take one day, and the numerical problem, and some small topics like under reamed piles also I have discussed, I think. So the only thing left in unit 5th is unit 4th is machine foundation, and some numerical problem which I will be sharing with you all people. In unit 3rd, we have discussed about the settlement and proportioning, importance and concept of settlement analysis, types of settlement, tolerance limits, BIS specification for total and differential settlements of footings and rafts, allowable bearing pressures I have also discussed in one of the PPTs, and factors influencing the depth of the foundation is also being discussed by me. Factors influencing the allowable bearing pressure has always been discussed, and factors choice of the. In unit 2 also I have discussed each and every parameter. If I talk about the vertical stresses, stress distribution under loaded area, I have discussed about the Bouzinek's theory and Westergaard theory for concentrated circular and rectangular roads, pressure distribution diagrams, contact pressure and Newmark's chart. In bearing capacity, I have discussed some of the definition like ultimate, net and safe bearing capacity, allowable bearing pressure, Terzaghi and Brenshansen bearing capacity factors, their assumptions and limitations. Bearing capacity of the footing subjected to eccentric loading, effect of the groundwater table on bearing capacity of the footing on the layered soil, field methods of the evaluation of bearing capacity, their limitation, plate load test, standard penetration test and cone penetration test. I think we are at the verge of completion of the syllabus. In unit 2, we have in unit 1 we have types of the slopes, causes of types and failure of the slopes, definition of factor of safety, stability of infinite slopes and finite slopes, and methods of slices, friction circle method, Taylor stability number, and its and some of the slope protection measures. So try to revise these topic. It is very important as far as gate examination is concerned, or engineering services examination is concerned, and also very much applicable in a field. So once I am sharing the problems related to gate previous year question paper, I am sharing the concept of geotechnical engineering one also, and I am trying my level best to make you all people ready for the gate examination. As far as my syllabus of my subject is concerned, that is geotechnical engineering 1 and geotechnical engineering 2. Not only this, I would be sharing some conventional question of engineering services examination once the gate previous year question is being completed. So students, in this topic we are going to discuss about the dewatering methods and suitability of the different dewatering methods. So what does dewatering means? Dewatering means removal of the excess water from the saturated soil. Dewatering is a necessary process when it comes to many construction projects, particularly when the construction is for underground projects. Dewatering methods: factors such as type of soil and nature of the construction site with all influence which dewatering method will be best suited to the project. That is, number 1, sump and ditches; number 2, shallow well system; number 3, deep well system; number 4, well point system; number 5, vacuum method, cement grouting, chemical process, freezing process, and electro osmosis methods. So what actually we do in sumps and ditches? It is the simplest and most commonly used form of dewatering. In this method, shallow pits called sumps are dug along the periphery of the area and connected by the drains of the semicircular in a shape and 20 centimeter diameter. So in this figure you can see the sump section over here. Side drains are being given over here. The water from the slopes flows under the gravity and is collected in the sumps from which it is pumped out. Shallow well dewatering: a hole of the 30 centimeter diameter or more is bored into the ground to a depth of not more than 10 meter below the pump level. A strainer tube of 15 centimeter is lowered in the borehole having a casing tube. A gravel filter is formed around the strainer tube by gradually removing the casing tube and simultaneously pouring the filter well so formed. The suction pipe from a number of such wells may be connected to one common header connected to the pumping unit. So this is a typical layout of the shallow well system. Deep well watering, bored well system: this system is more suitable when the depth of the excavation is more than the 16 meter or where artesian water is present. In this 15 to 16 centimeter diameter hole is bored and a casing with a large screen is provided. A row of a well point is frequently installed at the toe of the side slope of the deep excavation. A submersible pump is installed at the bottom of the well, of which the casing generally has a minimum diameter of 150 mm. The discharge pipes from the submersible pumps of a number of adjacent wells are connected to a common delivery main. The water is raised from the well by a multi-staged pump. This is deep well dewatering system. It is a typical layout of the deep well dewatering system. So in this figure you can see how this is pump control box, valve, and approximately existing discharge PVC pipe, grouted annular space minimum 2 feet. This is all things are dam core, subgrade. So in this way this dewatering is done. So now I would like to discuss about well point system. The main component of the well point system are well point, riser pipe, springer arm, header pipe, pumps. This is the ground level. Well point system is of the direction of a flow, riser and filter is being provided. So the well point system is perforated pipe 5 to 8 centimeter in diameter and 1 meter along the 1 meter long, covered by the cylindrical wire gauge screen known as strainer. Pipes are jetted in the ground 1 to 2 meter apart. Well point, riser pipe, springer arm, header, it is suitable for lowering water by 5 to 6 meter in a soil. So this is the way a single well point system is being maintained. Water table you can see: this is Griffin well point, this is groundwater drawdown, gravelly sand, fine sand, silty sand, and sandy loam. This is a way of arrangement of well point system. Multi-stage well point system, multi-stage. So in this figure you can see riser stage 1, riser stage 2, riser stage 3, and final top of the groundwater surface. When a water table is greater than 6 meter, this method will use. In this method, 2 or more rows of a well point system are installed. installed at a different elevation. In this method, wells are installed in two stages. In first stage, water table lowered by 5 meter. If required, then third stage of the well point can also be installed for further lower water table. This method useful for up to 15 meter. For up to 15 meter, that well system will be used. This is multi well point system. Advantages: installation is very rapid, the equipment is reasonably simple and cheap, as water is filtered while removing from the ground, soil particles are not washed away, hence there is no danger of subsidence of the surrounding ground. As the water is drawn away by well point from the excavation, the side of excavation are stabilized by steeper side slopes can be permitted. Disadvantages: single stage well point system is suitable for lowering water table by 5 to 6 meter only. For deeper excavation where water table is to be lowered for a depth greater than 6 meter, multi stage well point system is required. It is essential to continue pumping once it has been started until the excavation is completed. If it is stopped in between, it may prove to be disastrous. In case of the ground consisting of a stiff clay, gravel or boulder, well points are installed in a drilled holes, which increases the installation cost. So this is a vacuum system well point over here, and sand filter, water level in a filter. It has original water table seal and all those things is being provided over here. So in vacuum system, when draining is required for silt or clay which have the size less than 0.05 mm, that time vacuum system will require. The process is as follows: the well points are driven and 25 centimeter dia is provided around the well point. Install in a ground by forcing a jet of water under sufficient pressure. The sand of the medium to coarse size is then forced into this hole as rapidly as possible. This sand forms the filter medium. In the uppermost 600 mm to 900 mm, an impervious material such as clay is stamped to form the seal, the upper portion. The pumping is then carried out by the means of equipment capable of maintaining a vacuum in the well points and surrounding filter. In this way, the pressure around the well point is reduced to a small fraction of the atmospheric pressure. The ground is acted upon by atmospheric pressure, thus the soil becomes consolidated and under a pressure which is nearly equal to the atmospheric. Control of the groundwater by grouting. Let me see whether we are having this topic in our syllabus or not. Otherwise, I will not discuss these things with you all people. So students, I think we are not having by these methods grouting. We are having electro-osmosis methods. If these are some methods, I will share PPT with you all people. But this time I am not discussing these methods because this is not a part of your syllabus. Electro-osmosis method is a part of your syllabus. There is a chemical grouting in which then also we are not having in syllabus also. Then also I will discuss on. Briefly, I would discuss. You should know whether which are some other difference with the help of cement grouting also. Actually, once you will opt for elective like ground improvement techniques, so there you will come to learn about these methods, cement grouting, and all those things. It is a very vast subject. So, a little bit of brief description I would like to give about cement grouting. So, in highly permeable cohesiveness soil, the safety of the side slopes may be endangered through the application of severe pumping. In such cases, especially if control of groundwater is required permanently, by the methods of grouting can be used. The main idea is to insert fine materials or chemical around the excavation in order to reduce the hydraulic conductivity of the surrounding soil to a minimum. In other words, the grouting process creates an almost impervious curtain around the excavation. The grouting is conducted using movable pipes with holes. The grout material is injected under the pressure as it follows outside the pipes through the holes to fill the voids of surrounding soil. The material used for grouting may be clay, cement, or special chemical compounds. So this is the way grouting is being done. You can see grouting on the soft soil. This is actual way of doing the jet grouting or cement grouting. In cement grouting, the material which are commonly used for grouting is cement and water, cement rock, floor and water, cement clay and water, cement clay, sand and water, asphalt, and clay and water and chemicals. So chemical grouting is also can be done. The desirable properties of chemical, it must be able to modify the property of soil as desired. It may either increase the strength or decrease the permeability of the soil. It must be cheap, non-toxic and non-explosive. It must be in the form of the liquid with a low viscosity so that it can be readily placed in a soil, and it must be non-corrosive so that it can be handled with the common pumps and piping. It must be possible to control the gel time by the suitable means. So this is a process of doing chemical grouting. Chemical or cement is injected to prevent the soil from collapsing. Pressure gauge monitoring, all these things are being done. So some of the chemical grouting chemicals, like inorganic, if you all people have gone through chemistry, you all people might be knowing inorganic and organic chemicals. So some of the inorganic chemicals are sodium silicate, calcium chloride, lignochrome, lignosulfate. They are called silicate grouts. They are cheaper. Some of the organic chemicals are epoxy resins, polyester resins. They are also called resins grouts. They possess advantage of the low viscosity, precise control of gel time, and high strength. Freezing process is not a part of your syllabus. Once, like ground freezing, once you will in your syllabus we are having electro osmosis method. So this is an arrangement for electro osmosis method. This method is for fine grained cohesive soil such as clay, which can be drained or stabilized using the electric current. The method was developed El Casagrande in 1952. If the direct current is passed between two electrodes driven as a natural soil mass, the soil water will travel from positive electrode anode to the negative electrode cathode. The cathode is made in a form of the well point or metal tube for pumping out the seeping from of the well point, or metal tube for pumping out the seeping water. A steel rod, a pipe, or a steel piling of the excavation can serve as an electrode. The arrangement of the electrode is done in such a way that the natural direction of the flow of the water is reversed away from the excavation, thereby increasing the strength of the soil and stability of the slopes. The potentials generally used in the process are from 40 to 180 volts with electrode spacing of 4 to 5 meters. Uh, Vibroflotation process. The vibrofloat is a The vibrofloat is inserted into the ground and typically can be used to improve soil up to the depth of 150 feet. Vibroflotation utilizes water and mechanical vibration of vibrofloats to move the particle into the denser state. Typical radial distance affected from 5 to 15 feet. Bowser, Mazin in GmbH 2012 they have given about this process. The vibrofloat is suspended from a crane and seats on the surface of the ground that is to be improved to penetrate the material. The bottom jet is activated and vibration begins. The water saturates the material to create a quicksand condition. You all might be knowing about this. Basically, the quicksand condition is that is temporarily liquefying the soil material, which allows the vibrofloat to sink to the desired depth of the improvement. At that point, the bottom jet is stopped and the water is transferred to the upper jet. This is done to create a saturated environment surrounding the vibrofloat, thereby enhancing the compaction of the material. The vibrofloat means at the desired depth of improvement until the material reaches the adequate density. The density of the soil is measured by using the power input via the electric current of the hydraulic pressure as an index. As the material densifies, the vibrofloat requires more power to continue the vibrating, at which the point pressure gauge display at the peak is required power. Once this point is reached, the vibrofloat is raised one lift, generally ranging from 1 to 3 feet, and the compaction and issues until the peak amperage or hydraulic pressure and is reached once again. So this is a way of doing vibroflotation. Advantage of vibroflotation is vibroflotation process offers the following benefits. When the process is done properly, it will reduce the possibility of differential settlement, that will improve the condition of the proposed structure. It is fastest and easiest way to improve the soil when the bottom layer of the soil will not provide good load bearing capacity. It is great technology to improve the harbor bottoms. On a coast related standpoint, it helps improve thousands of cubic meters per day. It is faster than piling. It can done around existing structure without damaging them. It does not harm the environment. It improves the soil strata using its own characteristics. No excavation are needed, reducing the hazards, contamination of soil and hauling material out over the site. So suitability of the different methods of groundwater condition is number one, sumps and ditches for shallow excavation in a coarse grained soils, well point system suitable for lowering water table by 5 to 6 meter in soil, bored well system for coarse grained soil, and depth of excavation should be more than 16 meter, vacuum method, draining silty sand and fine sand, cement grouting for coarse material or rocks with cracks, freezing process suitable for excavation and waterlogged soil, electroosmosis method suitable for fine grained cohesive soil such as clay. So students, the only thing which has been left in this topic is like sand drains, stabilization and its methods, preloading by geosynthetic. These topics are being left, and it will take one day only, I think, to discuss about all these things. And I will discuss something about the samplers, sample disturbance, area ratio, their recovery ratio. All these things I would be discussing in one day, and machine foundation I will take one day to discuss all these things. Afterwards these topics will be completed. Your course of geotechnical engineering 1 will be completed once I would discuss all these topics. So try keep revising the concept, try to keep solving the numerical problem which I will be sending to you all people, and also keep solving the gate engineering examination question which has previously came in some competitive examination like gate and all those things. Try to revise it. Thank you once again. Thank you for listening to me.